Let's talk about receptors in the autonomic nervous system. This is a big deal. This is maybe one of the biggest deals of the entire fourth section of the course and maybe of the entire semester. There are two basic categories here. We have adrenergic receptors and we have cholinergic receptors. Okay? This is the first distinction to make sure that you are solid on. Before you go any further, make sure you've got this down solid, because people end up making mistakes on this, and this is the most basic stuff. Let's talk about the term adrenergic first. So adrenaline, the term adrenergic comes from the term adrenaline. Now adrenaline is exactly the same molecule as epinephrine. There's no difference, just two different names for the same thing. Epinephrine. Okay, well, whatever. Nephrin. Okay, epinephrine. Look at adrenaline, at renal, the kidney, at the kidney. In other words, from the adrenal gland. Epinephrine, above, nephro, renal, Latin root word, nephro, Greek root word. Both of them mean basically the thing on top of the kidney, which is the adrenal gland, all right? Now, noradrenaline is a very similar molecule to adrenaline. And noradrenaline can also be called norepinephrine. So these two are exactly the same, these two are exactly the same, and these are extremely similar to this. This is just a slightly different version of this molecule. If you think of all four of these things as being the same, you'll be okay for this class. If you're going to pharmacy school, that won't work. You'll have to learn later some important differences. But at our level, it's all the same stuff, okay? But I'm trying to get you to remember that adrenergic comes from adrenaline, which is the same as epinephrine, all right? And if you remember that, you should be in good shape. So, adrenergic receptors, as it turns out, the neurotransmitter in the ANS is norepinephrine. So always think of adrenergic receptors as being for norepinephrine, okay? You'll be fine if you do that. Everything will be okay. Now, cholinergic, these are receptors for acetylcholine. Look at the name, acetylcholine, cholinergic, okay? So get it? Acetylcholine, cholinergic. Adrenergic, noradrenaline, which is the same as norepinephrine, all right? So really it's the adrenergic, epinephrine, adrenaline group, and the cholinergic, which is the acetylcholine group. Now the easiest ones to talk about first, and we're going to do that and then erase this and start over. Cholinergic. There are two kinds of cholinergic receptors. There are two kinds of receptors for acetylcholine. One of them is called a nicotinic receptor, and the other is called a muscarinic receptor. These are named for compounds found in nature. Nicotine found in a lot of the plants in family Solanaceae. So tomatoes, potatoes, eggplant, tobacco, of course, chili peppers, all right? Those are all in the same plant family. They all have nicotine in their tissues, all right? And so nicotine, not normally found in your body, but not only can acetylcholine bind to a cholinergic receptor, nicotine can bind to this particular type. So a nicotinic receptor can be activated by either acetylcholine or by nicotine. That's why it's called a nicotinic receptor, but it's still a receptor for acetylcholine. Muscarine is found in a lot of mushrooms, not the psychedelic mushrooms, the ones that are more poisonous usually. So muscarinic receptors will respond to acetylcholine. It's a type of acetylcholine receptor, but they will also respond to muscarine, a compound found in nature. So these are the two kinds of receptors. Now nicotinic receptors we saw at the neuromuscular junction. That's the receptor there. And these are also at the preganglionic, they're on the ganglia, all right? These are the receptors on the ganglia in both sympathetic and parasympathetic nervous systems. Muscarinic receptors are what are found at the effector organ. So for the autonomic nervous system, we're going to be talking about muscarinic receptors almost exclusively. You can pretty much forget about nicotinic receptors for the rest of the semester here, except that they're found in various other places that we're not caring all that much about. It's at the actual organ where we have muscarinic receptors. So remember that cholinergic receptors, mostly all we're talking about are muscarinic receptors, okay? Now, I'm going to erase all this because the rest of the time we're going to be talking now about adrenergic receptors. They're the big deal. They're the ones we're going to focus on the most. So let's look at adrenergic receptors. Adrenergic receptors. And there are 5 types of adrenergic receptors. Actually, there are many more because there are many subtypes. So there are tons of types of adrenergic receptors. We're going to try to simplify it by narrowing it down to just 5 of them. Sorry, stay. They get named with Greek letters. Greek alphabet, alpha, beta, gamma, delta, epsilon, zeta, eta, theta, kappa, lambda, mu, xi, from pi, rho, sigma, tau, epsilon, phi, chi, psi, omega. All you in fraternities, sororities know that. So we have alpha 1, alpha 2, beta 1, beta 2, and beta 3. These are the 5 kinds of adrenergic receptors. Now, for our class, I want you to know alpha 1, beta 1, and beta 2. I'm not going to emphasize, and I'm not going to test you on alpha 2s or beta 3s. However, there are other instructors who in Bio 201 cover all 5. So when you get to Bio 202, other instructors may expect you to know alpha 2s and beta 3s. It's not a big deal. You might as well learn them now. I'm just letting you know I won't test you on alpha 2 or beta 3. But alpha 1, beta 2 you really need to know. Let's talk about what they do. What happens here is that why are there 5 different receptors? They're found at different places in your body, and therefore they do different things. And that's the biggest deal here, all right? So, alpha 1 receptors, these are found mostly in peripheral blood vessels. So, peripheral blood vessels means the blood vessels out on the extremities near the surface of your body, okay? Not blood vessels down deep inside. Blood vessels up on the surface, around the outsides of your body. What happens is when norepinephrine is released onto an alpha 1 receptor in a peripheral blood vessel, it causes vasoconstriction. Vasoconstriction. What does that mean? It makes the blood vessel get narrower in diameter. So the blood vessel gets narrow in diameter. As the blood vessel narrows in diameter, there's more resistance, and therefore the blood pressure goes up. And that's the big deal. These increase blood pressure. Why do we want blood pressure? Why do we want to do that? Well, this is the sympathetic nervous system. Adrenergic receptors are the receptors at the effector organs in the sympathetic nervous system. This is where, we've got, the crisis. The chupacabra has come through the door. We have to run, we have to fight, we have to survive, all right? We want more blood pressure to get more blood out to our muscles and to our heart and our lungs and so on so we can survive, okay? See, it makes sense is what I'm trying to say. You don't have to just purely memorize it. It's logical. It makes sense if you remember it, okay? Another place alpha 1s are found is in your pupils, well, in your iris. And what they do is this is pupil dilation. So once again, can you see why the sympathetic nervous system, that words are, looks like one giant word, pupil dilation, can you see why? In a crisis, you want to be able to see better, all right? Crisis, you say, oh my God, it's El Cucuy! Oh no, wait, it's just me, Tia. Tia, put down the chocolate! All right, so you want to be able to see better what's happening, all right? So alpha 1s help you see better the crisis. See how easy it is? Okay, alpha 2s. We find these 2 places, platelets, so those are in your blood, and also in the pancreas. So what happens in the platelets is, it causes, well, I don't know what color to use, never mind, I'll just use black. No, I'll just use blue. It causes blood clotting. In other words, it promotes blood clotting. Can you see why? If you're fighting a chupacabra and you get scratched or bitten, you don't want to bleed to death. So alpha 2s, in a crisis, norepinephrine gets released. it will stimulate their alpha-2 receptors in the platelets, and this will stimulate blood clotting, so you don't die from bleeding to death. And in the pancreas, what does it do? It decreases the secretion of insulin. Right? Insulin is what takes glucose out of your blood. So what happens when we inhibit insulin? Well, that means that we increase blood glucose. All right? And why would we want to increase blood glucose in a crisis? Remember, if we're running and fighting and everything else, we're going to need lots of ATP. What do you need to make ATP? Oxygen and glucose. So look, again, your nervous system is trying to help you out by giving you more glucose so you can make more ATP to fight the chupacabra, all right, or to run from La Llorona, all right? So, and then beta-1s. Where are beta-1s found? A couple different places here. So beta-1s are found in the heart. And what they do is they increase heart rate, they make your heart beat faster, and they also increase contractility. Contractility is how forcefully your heart beats. In other words, your heart can just kind of squeeze gently, or your heart can really squeeze hard. The harder your heart squeezes, the more blood it squeezes out. So can you see here, raising heart rate, raising contractility means you're getting more blood out to your body, all right? And once again, that's going to increase blood pressure. So you have more blood available in order to run and fight and survive, okay? All right? And another thing, another place where beta-1s are found are in the kidneys, where it releases a hormone named renin. And renin is a very important part of what's called the renin-angiotensin-aldosterone system, which we'll learn about extensively in Bio 202. And what does the renin-angiotensin-aldosterone system do? It raises blood pressure, one of the most important blood pressure control systems in the human body. All right, so that's beta-1s. Beta-2 are found in a few places. So they're found in the deep blood vessels, all right? The deep blood vessels, going to places like the heart and to the skeletal muscles. Right? And that makes sense when you think about it, because if we're running and fighting, our heart is going to be working harder and we need more muscle activity. So we're going to get more blood to those deep blood vessels, okay? Then it also, as a result of going to these deep blood vessels, one of the deep blood vessels that it dilates, actually deep blood vessels, I should have written here, causes vasodilation, causes these blood vessels to get bigger. So I'll write it over here. Vasodilation makes the blood vessels bigger in diameter so you get more blood to these organs, okay? And then another place you find it then is in the liver, where it promotes something called glycogenolysis. Glycogenolysis means you break down glycogen, which is a stored form of glucose, all right? And that's going to then increase your blood glucose, all right? You break down glycogen to increase the blood glucose. And the final place for our concerns, all these receptors are actually found all through your body. I want to make that clear right now. These are found in places everywhere in your body. I'm just focusing on the main ones that I think are important for us, okay? Also found in your lungs, where they do bronchodilation. Bronchodilation, in other words, it makes the pathways to your lungs bigger in diameter, all right? Opens up your lungs so that you get more what? You get more oxygen, so you can make more ATP, all right? And then beta-3, these are found in adipose throughout your body. And what beta-3 do is they once again promote, they promote what's called lipolysis. Lipolysis means breaking down fat, and when you break down fat, you can utilize that to get more blood glucose, all right? So, there we go. There are the receptors. Everything's kind of like, looks like we're on a ship, and we're like, things are, okay, we're in a storm. So look at what's going on altogether. These are the 5 types of adrenergic receptors. These are all for the sympathetic nervous system. The sympathetic nervous system. All right, so I especially want you to know alpha-1, beta-1, beta-2. You'll get tested on those. I won't test you on alpha 2 and beta 3, but you should know those anyway. You'll need them in Bio 202. In Bio 202, we talk about them basically the first week, okay? So might as well learn them now. But look at overall, what are the adrenergic receptors doing overall? They're increasing your blood pressure, so you get more blood to your body for the crisis. They're increasing your glucose and your oxygen, so you can make more ATP, so that you can defeat La Llorona, El Gogoy, the Chupacabra.